Assistant Professor, Department of Mathematics in SNS College of Technology. In this previous class, we saw what is diagonalisation of a real symmetric matrix. So, in this class, we are going to see one problem. So, see the problem. Reduce the matrix A 1 0 0 3 minus 1 0 minus 1 3 to diagonalisation form by orthogonal transformation. So here in this matrix is converted to diagonalisation form. We are going to using the following steps. What are the steps? As the first step is, what is that? It is first we have to find the characteristic equation, eigenvalue, and eigenvector. Then using this eigenvector, we have to check it is a pairwise orthogonal or not. Then what is that? Yes, it is a in this eigenvector we are going to change. It is a normalized eigenvector. So in this normalized vector we have to combining the normalized eigenvector, that is the normalized model matrix. Then that normalized model matrix is orthogonal, that is n transpose n equal to I. Then we are going to the last step is D equal to n transpose A into n is a diagonal form. So using this step we are going to solve this problem. Okay. So first we are going to see what are the steps are here. So here the first one is we have to find the characteristic equation. So it is a 3 by 3 matrix. So in this 3 by 3 matrix the characteristic equation is lambda cube minus C1 lambda square plus C2 lambda minus C3 equal to 0. So here we are going to simplify C1, C2, C3. Okay. So C1 is 7. How we can it is a 7? Sum of the diagonal element is C1. So that is 1 plus 3 plus 3 is 7. So C1 value is 7. Then we are going to solve the C2. So what is C2? C2 is nothing but sum of the minor of the main diagonal element. So here we are going to leave the diagonal element. So this is the diagonal element. 1, 3, 3 is a diagonal element. So here sum of the minor of the main diagonal element. So here first is we are going to leave the first row and first column. Remaining element is 3 minus 1 minus 1 3. Okay. Second. So here the second diagonal element is 3. So we are going to leave the second row and second column. So the remaining element is 1 0 0 3. Okay. So then we are going to leave the third row and third column 1 0 0 3. Then we are going to take the determinant. The answer is, so here see 3 into 3 is 9, minus and minus is plus, the formula having minus, so minus 1. Then 1 into 3 is 3, 1 into 3 is 3, 0 into 0 is 0. Okay. So minus 0, here also minus 0. So no need to put here. Okay. So 8, 3 plus 3. What is that? 3 plus 3 is 6. 6 plus, that is 6 plus 8 is, that is 14. Okay. C2 is 14. Then we want to see the C3. So here C2 is 14, C3 is determinant of the given matrix. So in this determinant we put positive symbol, negative symbol and positive symbol here. So here see, first we are going to 1. So multiply 1. So we leaving the first row and first column. So the element is 3 minus 1 3 here. Then we put minus. So 0 into anything is 0. Here also 0, take the element 0. So 0 into anything 0. So no need to write here. So here after the simplification we get the values 8. How it is 8? 9 then minus 1, that is 8. So if you know C1, C2, C3, then we are going to substitute here in the equation we get the characteristic equation. So in this characteristic equation is lambda cube minus 7 lambda square plus 14 lambda minus 8 equal to 0. So after that we have to simplify this equation as lambda equal to 1, 2, 4. So this is the eigenvalue. So in this characteristic equation, using the characteristic equation we are going to using calculator. How we are going to solve? It is a lambda equal to 1, 2, 4. Yes. we are going to press the mode button third time. So if it is equation S, this will it is equation under that 1 S. So then we have to press the 1 symbol. Then if we are asking unknown value, so no need to press the unknown button. Then we are going to press the oval button in the calculator. So in this oval button we have to press the number is, what is that unknown value? Here the unknown is 2, 3. No need to press 2, 3. Here we are going to press the oval state button. Okay. So then we are going to asking the degree. So it is a third degree. So if we want to press the A value is 1, that is the coefficient of lambda cube, then we want to press the coefficient of lambda square, then coefficient of lambda, then constant, that is C value. So after we are going to enter the value, we get the answer is 1, 2, 4. So this is the eigenvalue. So in this eigenvalue, we are going to simplify eigenvector. Okay. So how it is find the eigenvector? So you know what is that? A into lambda I into x equal to 0. So in this original matrix, that is A matrix, we are going to subtract the diagonal. Okay, so that is minus lambda, minus lambda, minus lambda. So that is the A minus lambda into I. Okay, then x is the element x1, x2, x3. Okay, so here we are going to, okay, here minus lambda and then minus lambda, minus lambda. So if it is substitute lambda instead of 1, 1 minus 1 is 0. Okay, so here remaining elements are 0, 0, 0, 0, 0, minus 1. 2. So if it is a diagonalist, 3 minus lambda is 2. So here also 3 minus lambda is 2. Okay, then x1, x2, x3. So here, see, if the 3 rows are different. Okay, so in this 3 rows are different. If it is a case 3 rows are different, we are going to using, yes, it is any 2 of the row. Okay, so I am considering second and third row. Why I am not considering the first row? If it is a first row, all the elements are 0. If it is all the elements are 0, no need to consider the first row. Okay. Why? The eigenvector is non-zero. That is, some values are having. Okay. For example, so no need to consider the first row. So here also we are going to using the cross rule. Here we want to starting 2 minus 1, that is 2 minus 1. Again minus 1 to 0, 0, 2 minus 1. Then we want to taking the determinant. Okay, combining this. So we get the answer is 3, 0, 0. So here the eigenvector is 3, 0, 0. Here also 3 divided by 3 is 1 and 0, 0. Similarly we want to check 2 and 4. So that is case 2 is lambda equal to 2. Here also similarly we replace instead of lambda 2, 2, 2. So then the matrix is this minus 1, 0, 0, 0, 1, minus 1, 0, minus 1, 1. So see here the 3 equations are same or different, or 2 equations are same. Yes, the 2 equations are same. Here see 0, 1, minus 1. But here 0, minus 1, 1. So in this third row we take minus outside. What is that? 0, 1, that is minus 1. So the second and third are same. So we using any 2 row. Okay. So here we want to combine 1 and 2. Okay. So I am starting x1, x2, x3. Here we want to starting 0, 1, 0 minus 1 and minus 1, 0. Okay. Again 0, 1. Then after taking the determinant, we get the answer is, what is that? 0, minus 1, minus 1. So this is the second eigenvector. So this is the first eigenvector, this is the second eigenvector. Then we are going to take the case 3. So the case 3 is lambda equal to 4. So if it is substituting lambda instead of 4, 4, we get the answer is minus 3, minus 1, minus 1. Remaining element are same. 0, 0, 0, 0, minus 1, minus 1. Then see, 3 equations are same or different? Yes. Second and third are same. First one is different. So we are going to consider first 2 using the cross rule. So here 0, minus 1, 0, minus 1, minus 3 0, 0 minus 1. After simplification we get the answer is 0 minus 3 3 equal to 0 minus 1 1. So this is the third eigenvector. So next class we are going to see how this eigenvector is pairwise orthogonal or not. Okay, thank you.